lines. So we'll go ahead and get started. This is an interesting topic just because there are parts of this that you can do without math, and then there are parts that you have to do math in order to, be able to compare. So let's start off with a little something easy. If I have something where I'm comparing these 5 different equations, let's say, well, let's just make them 4. Let's just make 4. All right, last one here. Okay, if I'm comparing these 4 and I'm asked to identify which lines are parallel, the thing you want to look for are the slopes. Which slopes are the same? The slope is going to be where it's written in slope-intercept form, which is going to be y equals mx plus b. Okay, so all of these are already in that form, so that's good. This one here, even though it says y equals x, well, that could be plus 0, and that's fine. That just means that these are the exact same number. So I am looking for my m's, which is located directly in front of my x. So I'm going to look at those numbers. Over here I have 5/3. So my m is 5/3. Okay, my m here, well, if there is no number written in front of the x, then we know it's a 1. Okay, so my slope there is 1. Right here, my slope again is going to be 5/3, just because I'm looking at the number directly in front of the x. And this one here, again, there is nothing written, but we know it's a 1. So I actually have 2 pairs of parallel lines here. The 2 that are parallel are the ones that have the same slope. So this one and this one are parallel, and that's because they have the same slope. And likewise, this one and this one are parallel because they have the same slope. All right, well, let's try one where we have to transfer it into slope-intercept form. So what if I was given these equations to compare? Y equals 2x minus 3. Y equals negative 2/3 x plus 3. 2x plus 3y equals 8. And then I have one. It's a little bit longer, so I'm going to write it down here. Y plus 1 equals 3 times x minus 3. All right, so let's go ahead and check off the ones that are already in slope-intercept form, which is y equals mx plus b. Y equals mx plus b. This one's good. Y equals mx plus b. This one's good. Y, no. Y, oh no. So these 2 I need to fix. So let's go ahead and fix this one first. So I'm going to rewrite it down here as 2x plus 3y equals 8. Now I need the y to be over here by itself. So the first thing I'm going to do is get rid of this 2x. It's a positive 2x because there's no sign directly in front of it, so we know it's positive. So I'm going to take the inverse and subtract 2x from both sides. That allows me to bring down my 3y and my equal sign. Now there's no other x value over here, so I just keep it at negative 2x. And this is a positive 8, so I'll just make it plus 8. Now I still have it 3y, where I need it to just be y. So right now I know that that 3 and that y are being multiplied, so I'm going to do the inverse of multiplying, and I'm going to divide that 3. Now I'm going to divide that 3 to everything on the other side. This allows me to cancel these 3's, giving me y by itself. So this is going to be rewritten as y. Oops, let me get rid of those. Y equals negative 2/3 x plus 8/3. And we're going to leave it like this just because when we're dealing with slope, you can have improper fractions. That's fine. So now this is in slope-intercept form. So now I can give it a red check mark. So this one is done. Okay, let's do this next one now. Right here. So let's rewrite it as y plus 1 equals 3 times x minus 3. All right, again, I want the y over here by itself, but if I notice first, I need to do some distributive property. So we're going to do our little double rainbow. 3 times x is going to give me 3x, and then 3 times negative 3 is going to give me negative 9. Okay, let's bring down everything else on the other side that we didn't touch. And now let's combine like terms. So I have a y here attached to a positive 1. So I need to get rid of this positive 1. So I'm going to take the inverse, which is to subtract 1. Now I'm only going to subtract it from the 9 because I can't subtract 1 from 3x. These two are like terms, they're both constants. Now over here, when we divided, you have to divide to everything. But when you're adding and subtracting, you only add and subtract to the ones that are similar. So the y falls down, and so does my 3x. And negative 9 minus 1 gives me negative 10. Now I have slope-intercept form. I can now give this a red check. So which ones are the same? So let's come in here. My slope on this one is 2, because that's the number that's right in front of the x. My slope here is negative 2/3. My slope here is negative 2/3. And my slope here is 3. So on this particular example, I only have one pair of lines that will be parallel. The other two will be lines on the graph, but they will not be parallel. So this equation and this equation are my parallel lines. All right, now what if we have something where we have to find out if there's a perpendicular line? Okay, that's a line that's going to be strictly horizontal or strictly vertical, and they meet forming a right angle. So we have something like this, where y equals 2x plus 2, y equals 2x plus 1, y equals negative 4, and x equals 1. Now if you notice right away, we have these two that are not in slope-intercept form per se, because they're just numbers and values. So these ones are already in slope-intercept form, and I know here my slope is 2, and this one my slope is 2, and these ones don't even have a slope. So I know that these ones are going to be parallel. What will these look like? Well, these are your perpendicular lines. Okay? All right. So if I graph on this, I am going to graph y equals negative 4. Well, where is negative 4 on the y line? That's going to be down here because this is the y line, this is the x line. So I'm going to go 1, 2, 3, 4, and this is negative 4. So I'm going to put a dot right there. Now it's natural to think, oh, it goes up and down, but no, you want the line that crosses through negative 4. So the line actually is going to do this. It's going to be a straight horizontal line. Okay, now our next one, we had x equaling 1. Again, on your x line, find your positive 1. It's right here. And I need the line that crosses through 1. And that's what it's going to be. It's going to be a vertical line. Okay? And that's how you know that those ones are going to be horizontal or vertical, and that's because there is no slope, or they're undefined, depending on which type of problem you have. All right, let's go ahead and try some more. So what you're going to do is you need to find the slope first, because none of these are written in slope-intercept form, and that's because you don't have a slope. So if you remember, your slope formula is m equals y2 minus y1 all over x2 minus x1. Okay, now this is going to be my first set, second set. So I'm going to tell you which ones. This one is actually my first set compared up with J. And I know you're not looking at the image right now, but I am. So just kind of take my word for it. Those two are together. So let's find the slope of those. So I'm going to go ahead and write M equals. Now y2 is my y from my second set, which is 3, minus my y1, which is my y1 from my first set, -1. All over x2, which will be -1 from my second set, take away x1 from my first set. All right. Now I know a negative and a negative make a positive. So this is 3 plus 1, which is 4. Okay, a negative and a negative again make a positive, but I still have -1 plus 2, which is just going to be 1. So my slope for this one is 4 over 1, or 4. But when finding a slope, remember you have your rise over your run. So it is kind of important to have both numbers, even the 1. Now that is the slope of these two lines. Okay, now on a parallelogram, it's kind of something like this, where all sides are parallel. And what I just proved was these two sides are parallel. So I'm going to locate the positive 3 on the y line. That's going to be 1, 2, 3, making a dot here. And I'm going to cross my line through that point. Okay, so this is y equals 3. Now, my x equals -2 is going to be a vertical line. And these two lines together will form that perpendicular line. So again, x equals -2. That's going to be over here. That's going to be 1, 2, putting my dot right there. And I will draw my perpendicular line now, crossing through that point. And this one is x equals -2. This intersection here is a perpendicular line. Okay? Now let's go ahead and graph y equals 3x. Okay? So by the slope of the line described by y equals 3x is 3. Now remember, that could also be 3 over 1 because our rise over our run. The slope of the line described by y equals -1/3 x times x minus 4 is going to be -1/3. So the slope over here is -1/3. Okay? So when we go to graph those, we need to make sure that we, include that rise over that run. So right here, this is plus b, right? Plus b would be over here, but there's nothing there, so that's 0, 0. So at 0, 0, I'm going to go up 3, 1, 2, 3, and over 1. Putting my dot here and here. So I'm now going to connect these lines the best I possibly can here. Okay, and this one is y equals 3x. Now let's go ahead and graph this one, which, let me go ahead and do distributive property. That's going to be y equals -1/3 x plus 4/3. Okay? Now 4/3, of course, can be written as 1 and 1/3. So it's a little bit after the 1, basically. So I'm going to go 1, maybe like right about here. Okay? And then I'm going to go to -1/3, which means I'm going to drop 1. So I'm going to drop 1 and run 3. There's 2, 3, 4. All right, so I'm going to drop, run, 2, 3, right about there. Okay, let's go ahead and connect those dots the best I possibly can here. And you'll see that we formed another perpendicular line. So we have two sets of perpendicular lines just by forming those two. These ones are always going to be your easy ones because you don't have to find what the y-intercept is. Okay. Well, I hope this helps you on your homework for tonight.